In this lesson, we're going to look in a little more detail about what an object is. We're going to clarify that. We've talked about them before. We're going to look at two specific types of objects that are predefined in Java. And we'll look at objects as parameters, return types, and what it means to be immutable. Mutable meaning change, what you can change in an object. Okay, so first of all, an object, we already talked about this, but again, it's a kind of a strange concept. So just to get the idea down, it's just a collection of data. It provides a set of methods. So we have a string object. Remember, a string is a class or an object. So a string is just a string of characters, and it provides a set of methods to operate on it. Index of is one of the methods. Substring is one of the methods. Equals is one of the methods. So that's basically what an object is. How does a class compare to an object? Well, a class is really the basic definition of what the object should look like, and the object is the thing itself. An example in real life of how this might compare is, for example, if you have a map of this school building. Suppose, on a piece of paper we have a layout of the school. It shows where all the classrooms are. That would be the class. That's like the blueprint of it. The actual school is the object. Another example might be, well, I guess it's the same idea for a house. You have a blueprint for a house. The actual object is the house. You might have one blueprint. You can make a whole bunch of houses that look the same out of that same blueprint. So the class exists once. The objects can exist as many times as you want. That's why when we declare an object, we declare what it actually is, what type it is, and then later we have to do the new statement to actually create the memory location of where that actual object will be. And sometimes, again, as we've done before, you can do that in one statement. So when we say Java is object-oriented, it just means it uses objects to represent data, and any type of data that you have, it provides methods related to them. The reason a class is such a powerful construct is that it allows you to set up the data and, again, the methods that are related to it and encapsulate it so that people can use that class without really knowing what goes on. We use the string class. We've used the arrays class. We have no idea what those functions look like inside when it's comparing or finding the substring, but we don't need to. And we can't really get to them. Well, we could look at them if we had the Java source code, but we have no need to change them. And that's why, for the most part, a lot of the classes have private instant variables which are immutable, meaning they can't be changed. So we can't mess around and accidentally mess up the string class when we're doing our program. We can mess up our own code, but we can't mess up anything in there. So one of the first classes we're going to look at in more detail is called a point. This is eventually used for graphics, but we're going to look at it in the simple case to just get down some of the basic ideas of how to access some of the methods within one of these classes. Okay, so when we look at the point class that's predefined in Java, we will import where it's actually defined. So it's defined in the AWT Java package, which stands for Abstract Window Toolkit. When they say abstract, it means it's like an abstraction of a graphics window. So it kind of represents the window internally. So it contains a point. We'll see later it also contains a rectangle and a bunch of other things, but these are the two we're looking at. So the first thing I do is declare the point. I declare it. I didn't give it any values. I didn't allocate space for it. So I know that anytime I see the variable blank in my program, it's going to be one of these points, something from the point class. Okay, if I want to actually allocate space, I would have to do a new. So now blank actually exists. So before, it's kind of like before you build your house. You say, my house is going to be using this blueprint, but the house doesn't exist yet. As soon as I say new, now I have a new house. I have an actual house. So this gives it an actual, it's called an instantiation or an instance of the object. Remember, a point is just like the coordinates in an XY plane. It has an X and it has a Y. X goes across, Y goes up, just like in regular math. So it has, if I create this new point with a 3, 4, that means the X field gets a 3, the Y field gets a 4. So I have a point at location 3, 4. Now suppose I want to take out the X coordinate and store it into just a regular integer X. That's what this does, this statement. It says blank.x because blank is the object I'm talking about. So it says go to that object, give me the value of the X instance variable, because that's just a variable within that class. So give me the value of x, assign it to this integer x. So I could use that same value this way, blank.x, or now since I've assigned it to this, I can use it as just plain old x. Now we've used methods previously where we pass in a string as an argument, or maybe we pass in an integer or a double as an argument. You could also pass in a whole object as an argument. So this defines a method that will print out the values, the xy coordinates of the object P, the object point. Okay, so all it does is it declares it just like you normally would, passes in the object. It's called P now. Whatever it was called previously, when I'm actually using the method, I'm calling it P. So what it will do is it'll print out parentheses. Remember, this is a concatenation when you're talking about strings. It'll print out the integer value or whatever it was, decimal value of the point, the x coordinate of the point, concatenated with a comma, the y coordinate, and concatenated with a closing parenthesis. So I want to print out this, it'll display this. If I did a print point on blank that I've defined up here, it should print it out like that. Another built-in method that or object that we're going to be looking at in Java, and again, this is in the AWT, the Abstract Window Toolkit for abstracting what you're eventually going to put on a screen, is called the rectangle. So I create a rectangle. Remember, I could do it in 2 statements, like I did up here, or I can do it in 1 statement. 1 statement's usually easier, I think. So I declare something called a box. It's a type rectangle, and it has an xy coordinate of the upper left, where the upper left corner of the box will be, and it shows the size of the box. It shows the width and the height, and these are all in pixels. So this kind of explains it again. It's in the upper left corner, because that's 0, 0 is the upper left corner, so it'll be in the upper left corner of the screen, and it's got a width of 100 pixels, a height of 200 pixels. Now suppose I want to make a method, I want to write my own method that finds the center of the rectangle. Well, the center is really take the width divided by 2, take the length divided by 2. That makes sense. Why do I have to add this box xy coordinate to the width and the length? Well, it's fine if my xy coordinate of the upper corner is 0, 0, but if it's not, I have to offset it as many pixels as half the width was and half the length was. So that's why I need to add it to the initial value. Okay, and then I just return what the point is. I'm returning a new point that has that xy coordinate of the center of the actual rectangle. Now remember, this is a case where I'm doing a return value that's an object. So I have to actually allocate the thing. So it's returning a new point with those xy coordinates. Now, one last thing that's important to know about classes and objects, if it's something called mutable, means it can be changed. Some of the fields can be changed. If it's immutable, the fields cannot be changed. And an example we looked at about that was string. If it's mutable, you can change the objects and all you have to, not the object, you can change the instance variables in the objects. All you have to do is make an assignment to one of the attributes. And it makes sense for point to be mutable because you might want to move a point around. So all I do is I have box.x. Box is my object. I want to change the x coordinate. I just offset it. I basically move the x coordinate over 50 to the right. I can do the same with the y coordinate. So sometimes it makes sense to have mutable objects where you can change the fields, like in this case. Sometimes it makes sense to have immutable objects where you cannot change the fields, for example, in a string. Well, let's take a quick look at some code here. So remember, we're looking at the point and rectangle objects. We first have to import them from the AWT or the Abstract Window Toolkit in Java. So here's the name of my program here is point rect. So let's take a look at it. The main is the first thing. It's not always true, but in this case it is. So remember, execution starts at main, so this is where I'll start. So I declare a point. All right, and now actually allocate anything. It doesn't exist yet. This just tell me the thing called blank is going to be a point. It doesn't exist yet. So, okay, now it exists. I created a new point. I assigned it to blank. I basically told blank, oh, here's where your point is in memory, so you have it now. When I do a println of an object, remember blank is a point object. When I do a println of an object, previously when we've done that, we've gotten just an address of the object. By default, that's what will happen. Println calls the toString method, if it exists, and if it's been redefined, which for point, the toString method has been redefined to print out something useful. So rather than just printing out the address of blank when I do a println invokes the toString method of the point class, which in our case, for point, it actually prints out something useful. It will print out the x and y coordinates. If you're interested in seeing what's happening there, you can look for the source code of print online. The source code is for all these libraries is out there. And when you look at it, just look for the toString method, which is overridden. It's overriding the default one, which prints out the address. So instead it prints out, in this case, x equals 3, y equals 4. It prints out something helpful. That's why it's been overwritten. Who cares about the address? Well, there may be some cases where you care about the address, but in general, we don't. We want to know what the x and y are. So that one does what we'd expect it to, strangely, instead of printing out the address. Now this is what I talked about. I could assign blank.x as an int. I can assign it to another int. I'm not doing anything with it. I'm just showing you how that works. So now I'm going to print out the x value concatenated with a comma, concatenated with the y value. So it'll print out x comma y, or in this case 3 comma 4. Now this statement shows how I can assign an integer variable called sum. I can assign x squared plus y squared. I can access those variables just like anything else, but since they're within a class or within an object, I have to do blank.x to differentiate between the regular x that I have here. So there's really two different things going on there. Okay, now I create a rectangle. Remember, this is the upper left corner of where on the screen where it'll be at 0, 0, so it's going to be way up in the upper left corner. And I want it to be 100 across and 200 high. Those are my pixels. The next thing I'm going to do here is move the rectangle I just created. It used to be at 0, 0. Now I'm going to take the box that I just created, the rectangle I just created, and I'm going to move it 50 to the right and 100 up. And we can look at what move rect does. Here it is. All it does is take the x, add whatever to it, take the y, add whatever I say to it. So this says take the x, move it 50 to the right, take the y, move it 100 up. I think that's what I had, 50 and 100. If those were negatives, if the x was negative, I would be moving it to the left instead. So here it is. Yeah, if this was a negative 50, it would say move it 50 to the left instead. Okay, then I'll print out my new values in my box. Okay, now I'm going to do a translate. Now, how do I know if translate is a method that's called from within the class or a method that I defined myself in my own class that I'm writing? Well, as soon as you see that box dot, you know that this translate method is a part of the rectangle class or the rectangle object. So it's one that I don't know. I don't really know what it does. It sounds like it moves it 50 to the right and 100 up. It sounds like it does the same thing as my move rect, but we can check by looking online and trying to find the documentation for the rectangle class. So all I did was search for Java rectangle class. I looked at the one that looks like, usually the documentation is from Oracle because they're kind of holding and supporting Java right now, but you could probably find a bunch of other ones. So anyway, it tells it's in this package. It shows what the rectangle is, what it does, what's its purpose. I'm going to page down a little. I'm going to look for what the methods are. It tells what the fields are. We already know the fields. We know that this is the height and width. We know the x and y coordinate of the upper left. So, and now we look at the methods. It can do all these things. I can add things to it. I can get boundaries, but I'm looking for translate. Oh, here it is. So it says it translates this rectangle the indicated distance to the right along the x-axis and downward along the y. So that's kind of what I expected. But it's just good to look at it to know for sure what's happening. So now again, I can create a new rectangle. Now I have box 1. I can assign it to another object of the same type. So these both point to the same thing. I could print out the width of it. I can make the box grow using, again, this is a method from within the rectangle class. I would have to look on that documentation page that I just looked at to see what grow actually does. So let's take a look at that page again, the manual page, and let's see what grow does. This is still the rectangle documentation. I'm looking for the grow method. Okay, there it is. It says it resizes the rectangle both horizontally and vertically. So it's just going to make it now 50 across and 50 high. So it's just interesting to see specifically what that does. So let's just see what happens when we run this thing. So compile it. I try to run it. And there's my output, just like I expect